Mraz, hi. I didn't get that email till this morning. Turned in a little early last night, so my apologies for that. Um, but here's a go on electron transport chain just as well. Let's take a second to orient ourselves. So this is an overview of all of cellular respiration. We are glucose is diffused into the cell. We've gone through glycolysis in the cytoplasm. That has moved pyruvate into the mitochondria, where it's gone through the Krebs cycle. Okay, those two things produce a little teeny bit of ATP for us, but not much. And then that goes into the electron transport chain. The electron transport chain enzymes are embedded in this inner membrane. Okay, so you've got an outer smooth membrane and inner convoluted membrane, and the enzymes for the electron transport chain are embedded in that inner convoluted membrane. Okay, a little more close up looks like this. So now in this picture, electron transport chain up here is in the cytoplasm. Okay, here we have our, this would be our outer smooth membrane. This would be our inner convoluted membrane. Okay, in tan here is the inner membrane space. And in what looks kind of like a peachy salmon color is the mitochondrial matrix deep inside the mitochondria. So here are the electron transport chain enzymes embedded in that inner mitochondrial membrane. Their job is to take the hydrogens from the NADH, your niacin, your FADH2, your flavin. Okay, it's going to take the hydrogens from those and force those hydrogens into the inner membrane space. Okay, as you can see here, I like this picture because it shows the concentration gradient of the hydrogen ions. We're really building up a lot of hydrogen ions there. They cannot flow back through these enzymes. There's no physical way to do that. Okay, since they're charged, they can't flow back through the membrane. Okay, so they only have one out. They have to flow back through the ATP synthase. That's the only place they can move. So now we have what's called the proton motive force. As these hydrogen ions flow through the ATP synthase, they physically turn the bottom of that enzyme. Okay, in a process that's called the chemiosmosis, happening right here in the ATP synthase. And that physical movement, the movement of kinetic energy, is transferred to storage of chemical energy as we add a free phosphate to the ADP. Okay, and in this way, we can make a whole lot of ATP, upwards of 32 of them. Okay, here's another close up on the chemiosmosis. So here's your inner membrane space. Here's your mitochondrial matrix. Okay, moving those hydrogens into the inner membrane space. They can only flow back through the ATP synthase, and that kinetic energy is transferred to chemical energy as the bottom of that ATP synthase embedded in the inner membrane moves. I hope that helps. You sure have worked hard on this, so walk into it with a bit of confidence, and you're going to do just fine. All right. Hey, thanks for the email, and let's go.